So this section is called Properties of Logarithms. And there are three properties of logarithms that we're going to work with. One of them is pretty clearly more significant than the other two, at least for our purposes. So we'll spend rather more time on this first property. This first property, and there is a third person after all. This first property allows you to simplify the logarithm of a power. So the logarithm and the exponential function are inverses. But if you want a logarithm and an exponential expression to cancel out and leave you with the exponent, then the base and the exponent must be the same. If we had, for example, the logarithm base 2 of 3 to the power of x, then because these bases do not match, cancellation doesn't occur, and this isn't equal to x. However, we do have a rule that works even if the bases do not match. And that rule says that if we have a logarithm of a power that takes the power and moves it down in front of the logarithm. So I'm going to get a little ahead of what the book does. The book presents this rule and then two other rules, and it doesn't really use them for anything until the next section. But I think it's probably worth illustrating how we can use this rule. What's it good for? Well, it's good for solving exponential equations. And I intentionally selected an exponential equation that we can solve in our head. 3 squared equals 9, so that we'll be able to check our answer after we get it. So we already know a way of solving this exponential equation. This rule gives us a second way. We'll take the logarithm of both sides of this exponential equation. But instead of a logarithm base 3, let's use a nice logarithm. And by nice, I mean a logarithm that has a button assigned to it on the calculator. Let's take the common logarithm of both sides. Now, on the left-hand side, we do not have cancellation. This is the logarithm base 10. Here the base is 3. Those do not cancel each other out. But what we can do, according to this rule, is take this power down in front of the logarithm. X times the common logarithm of 3 equals the common logarithm of 9. X times a number equals a number. X is the common logarithm of 9 divided by the common logarithm of 3. And that works out to what? Let's go to our calculator. The common logarithm of 9 divided by the common logarithm of 3. And that checks out. I mean, stop share. We went into this knowing the answer, and this process did give us the correct answer. Now, there's another way we could have approached this problem. The way we approached a problem like this last week would have been to take the logarithm base 3. of both sides. On the left, now our bases are the same. We would have had cancellation. X equals the logarithm base 3 of 9. Now, assume that you have an ordinary TI-84 calculator and not a later edition. You can't plug the log base 3 of 9 in there. So what could you do? Well, you could use the change of basis formula. You could rewrite it in terms of the common logarithm. The change of basis formula gives you the common logarithm of 9 over the common logarithm of 3. And of course, no matter which route we took, whether we started with the common logarithm and then divided, or whether we started with the logarithm base 3 and then used the change of basis formula, we wind up in the same place. The common logarithm of 9 over the common logarithm of 3, x equals 2. I mean, we already typed that very thing into our calculator. So we can solve exponential equations. Like I say, though, we're getting a little ahead of ourselves in terms of how our textbook handles this. Our textbook really addresses exponential equations in the next section. Let's present 2 more rules for working with the logarithms. So let's follow the same order that the textbook does.